Another dash off video. This one is just kind of like right where I'm at in my head. It has to do with the icosahedron and the jitterbugging from a cuboctahedron. But I'm not dealing with the edge 2 cuboctahedron. I'm dealing with the square root of 2 edge cuboctahedron and the square root of 2 times phi cuboctahedron. And what I've done here is I've got the two cuboctahedra. Here's the inner one. I don't know, inner triangle. I have this perspective snap on. I'll take it off so I can work it better. But yeah, this here is your cuboctahedron on the inside. Here it is on the outside. It gets bigger. The triangle gets bigger in quite a hurry. Now, in a prior video, I discussed that the icosahedron actually hovers exactly between those two, which I think is fascinating. And there's the icosahedron. I forgot the points, but it doesn't matter. If you look right here, you can kind of size up. Maybe I should get that chunk out of the way. Anyway, right there on your right here, you can see that there's kind of a halfway point. It truly is halfway. So what I'm going to get at now, get rid of that icosahedron, is this combination of triangles here. These outer two triangles are part of the icosahedron. That's why the edge here, right from here to here, actually resides on the surface square of this cuboctahedron right here. But what I'm really showing here is the in another video I've also showed that there was a S module kind of jumping from the 1/8 octahedron to an S module, and then the next shape was a Q module, but it's not an exact Q module because it's not to the proper scale, but it's the Q module form, and that's really has an equilateral triangle surface. And so what I'm showing here is equilateral triangle surface here, and they're obviously they're penetrating each other, and that's the interesting thing that's going on. In reality, we actually have PQ and R modules functioning here. I'm not going to get too deep into that. I just wanted to just kind of show you what I think is a kind of an interesting behavior, let's say, if you were tracking the jitterbug's motion. It's almost like a 19th century mechanistic thing. You can see the guy with the curly mustache and the round top hat and riding a big wheel tricycle. You know, one of those kind of diagrams, like a patent drawing. But that's kind of a mechanized look of a jitterbug process where, let's take this edge here, or line, I mean, and then we have two of them. Look at those as like hinges, and this triangle can hinge, and it can go. The point goes from here to here. At the same time, these 2 points go the same distance downward to here. That's kind of what I'm saying. There's this flapping, let's say. It's very mechanized, and obviously it's happening at all 6 squares. And this is not the true jitterbug because this outer cuboctahedron is phi times the square root of 2, which is like 2.288. It's a much larger than edge 2. So what I'll do real quickly here is I'll show you the combo of all of them. And it is kind of interesting. I mean, we have this channel that's going on for the tetrahedron portion of the cuboctahedron that's kind of almost independent of what's going on, not entirely, of what's going on with the cuboctahedron or the half octahedron square face portion. One thing I failed to mention before was that, and this is not going to be described well here, but you had an 8th octahedron, and then you stepped up one of the rays by phi, and you got an S module. And it's not the true S module, of course, because I'm dealing with a different edge length, but it's S module form. And then the next step of phi, you got the Q module form. The next step of phi, you get an R module form, but you get some extra. You get this extra bit, and it's kind of like here. It goes like from here to here, down to here, and it's actually, if you took that edge of that R module form and projected it, what am I trying to say? If you extended the one of its lengths by phi, you would get this form. So in effect, what I'm trying to say is it's this part with the added to that R module form is yet the S module again, the volume of the S module. So that's that part that's extra, let's say, and it's from here, here. I don't expect you to remember all this, and of course I don't even have a edge there to look at, but yeah, it's very fascinating to me that could be possibly a mechanized way of going. I'm going to show something real quick here, and I know these edges are orange, but the oranges are the same as the reds, and they have to do with five-fold symmetry, but it's just kind of fun. This is a rhombic trioctahedron face, but here you can see that there's only 6 of them, and then there's not just triangles, but there's a little more to it. There's like this distance here, from here to here on each edge. The longer edge connects. I think that's kind of cool, personally. This edge here is the edge of the icosahedron, which is not true in the super RT, but there's an interesting relationship.